When we look at our solar system today, Earth is the only known planet with stable, life-supporting conditions. But billions of years ago, the situation may have been different. Mars, for instance, shows strong evidence that it once had liquid water, a crucial ingredient for life. Ancient river valleys, dried-up lake beds, and water-altered minerals tell the story of a wetter Martian past. Even today, Mars retains ice at its poles and sometimes frost in its soil. This leads to a natural question. Could Venus, often referred to as Earth's twin, have once been habitable too? Venus is almost the same size and mass as Earth, and it's composed of similar materials. Yet its surface conditions today are extraordinarily hostile, with temperatures exceeding 460 degrees Celsius, 860 degrees Fahrenheit, and an atmospheric pressure over 90 times that of Earth's. The air is filled with carbon dioxide, and clouds are made of sulfuric acid. But despite this, scientists have long wondered whether Venus may have once had oceans, clouds, and a more temperate climate suitable for life. In contrast to Mars, Venus doesn't preserve much evidence from its ancient past. The surface appears to have been entirely resurfaced by massive volcanic activity sometime in the last 500 million years. These catastrophic events could have buried or destroyed any signs of ancient oceans, river valleys, or coastlines. As a result, we lack the geological evidence that makes Mars's watery past so convincing. Adding to the puzzle, Venus today has no detectable water. There's no polar ice, no signs of seasonal frost, and not even trace amounts of water vapor in its thick atmosphere. This stark absence doesn't necessarily mean Venus was always dry, but it complicates the case for past habitability. If Venus did once have water, where did it all go? Water consists of hydrogen and oxygen. Hydrogen is extremely light and easily escapes into space when exposed to solar radiation, especially if a planet lacks a protective magnetic field. But oxygen is heavier, and unless it binds with surface materials or escapes in some other way, we'd expect to find more of it in the atmosphere. On Venus, however, we find almost no free oxygen at all, an indication that if water was once present, it was either lost very early in the planet's history or never existed in large quantities to begin with. Some scientists propose that Venus could have been habitable for a short time. Recent climate simulations have tested this idea. Of the many scenarios modeled, only a small fraction allowed Venus to maintain stable surface water for even a limited period. Most outcomes showed that any oceans, if they ever formed, would have evaporated within a few 100 million years. In only the rarest cases did they last longer than 1 billion years, a relatively short time in planetary terms. What could have caused Venus to take such a different path from Earth? One key factor is its position in the solar system. Venus is closer to the Sun and receives nearly double the solar energy Earth does. But early in the Sun's life, it was much dimmer, meaning the region where liquid water could exist was closer in. It's possible that Venus was once inside that early habitable zone. However, the planet's extreme day length may have played a role in its downfall. A single day on Venus lasts longer than its year, about 243 Earth days, and the planet spins in the opposite direction of most others. This slow and retrograde rotation could have led to severe temperature contrasts, extreme heating on the day side, and an unstable climate that made it difficult for water to remain on the surface. Another important difference is that Venus has no moon. Earth's large moon helps stabilize its tilt, which in turn moderates climate over long periods. Without a moon, Venus may have experienced wild variations in its axis, further destabilizing its climate. Some researchers have speculated that Venus might once have had a moon that later fell back onto the planet due to tidal forces, potentially contributing to the resurfacing events and even to the loss of water. It's also possible that Venus, like Earth, experienced a giant impact early in its history. Earth's moon is believed to have formed from a massive collision between our planet and a Mars-sized body. That impact not only created the moon, but also could have influenced Earth's rotation and early atmosphere. A similar impact on Venus might explain its unusual rotation and may have disrupted any early oceans or atmospheric stability. However, direct evidence for such an event on Venus is lacking due to the young and volcanically refreshed nature of its surface. One broader question is how Earth, Mars, and Venus acquired water in the first place. A leading hypothesis involves the late heavy bombardment, a period around 4 billion years ago when a flurry of comets and asteroids may have delivered water to the inner planets. Earth and Mars appear to have benefited from this bombardment. If Venus was part of the same process, why didn't it retain its water? The answer may lie in its proximity to the Sun. Venus's hotter environment would have caused water to evaporate more quickly, and any water vapor in the atmosphere could have contributed to a runaway greenhouse effect. Water vapor is a powerful greenhouse gas. The more of it in the atmosphere, the more heat gets trapped, which leads to more evaporation. A vicious cycle that may have spiraled out of control. This scenario could explain how Venus transitioned from potentially wet and mild to dry and scorching in a relatively short time. Taking all the available evidence into account, the likelihood that Venus was ever Earth-like is low. Most signs point to a planet that never had long-lasting surface water, or one where any water present vanished very early. While Mars seems to have had a longer and more stable window for potential habitability, Venus probably never sustained conditions suitable for life as we understand it. Nonetheless, Venus remains an essential subject of study. Understanding why a planet so similar to Earth in size and composition ended up so uninhabitable teaches us crucial lessons about planetary evolution, climate dynamics, and the delicate balance required for life. As we discover rocky exoplanets orbiting other stars, some of them in tight, hot orbits, we'll need to understand the difference between a true Earth analog and a deceptive twin like Venus. In the end, Venus offers more than just a cautionary tale. It provides a natural laboratory for testing our theories of atmospheric physics, planetary formation, and climate feedback loops. Studying Venus could ultimately help us protect Earth and identify which of the countless planets out there might truly be capable of supporting life.